carbon in addition to the organic loading, right? This is also one of the case study where the technology is in place for more than 2 years and working very well. The treated water is used for land application. So, as I mentioned, we have different types of examples I have given you, right? Then we will start, and after that 2:30 I may take 10 minutes more. We'll just average that and then we'll finish, right? Do you have any questions so far? What you have learned? This is a very well developed integrated. I have always tried to add whatever we are reading or understanding or learning, it is implemented on the site. So it is not like that something you are reading and which is not there in the books. No, it is already done. Many papers we have done on that, and the reports we have done, they are very well documented technologies. So that is why always, if you are in the field, make sure that you know about more and more developed technology. Sometimes non-conventional technologies are much more preferred for particular type of pollutants to remove from the system, right? So that is what wanted to bring up to you, how the system is developed, how the same model can be applied here, what are the different components, how you can understand to make it more successful program, what are the things needed, at least that is important. Then one by one we should. Yes, go ahead, Professor. Yes. Non-contact cooling water is the wastewater coming out of big data centers. Your data centers which are here, there are big cities which are built for data centers. Your data is stored there. So they need an air conditioning all the time, entire building, big farm. They are called data farms. Google, Yahoo, Sebis, right? All kind of big computer companies. They have their farms, they have their equipments where their data is stored all the time, 24 hours, 365 days. They need a lot of water to maintain a particular temperature all the time, right? So that is why they produce a large quantity of non-contact cooling tower. Your air conditions, they use a little water, and there is a process also. What happens in the non-contact cooling water? What is the main pollutant? When there is certain volume of water is evaporated, as the evaporation takes place, the concentration in the wastewater increases. TDS concentration is high. I said it gives rise to a different issue. If the TDS concentration is high, what happens? It enters the underground reservoir. There is a limitation where you want to dispose that up. You have to remove TDS. That's why we adopt the reverse osmosis process. What is our target component? Target compound is the TDS. We remove TDS. If BOD remains BOD won't be there at all, very less, nothing like pH variations, and then treat that water, recirculate, until it is used, then discharge. That is why those farms are big in the sense one cannot imagine. I have few data centers with me. They even entirely change the groundwater situation. Even though if they are treating, if they are not treating, you can imagine what is the gravity. Groundwater standard, please sit down. Groundwater standards, we have a TDS for 500 milligram per liter. If they are discharging, that comes up with some other problems, some other issues. It also depends on the influent water. When you say the effluent, what is the influent water? TDS. Because if you are pulling a lot of water from the groundwater TDS also you should check, right? If it is a 300, 200 TDS in the influent, you can't put some restriction 100 because it is 300 here, right? So that is why they have a different kind of issues. So that is why they want to go for reverse osmosis, maybe expensive, non-conventional treatments, right? They do treat, recirculate, and then discharge. That is all. Okay, this is the tutorial number 5, pollution prevention, case study PCB removal in beverage industry, just for your academic purpose. Okay. Okay. We can do that. Okay. Project is for facility primarily engaged in. Okay, go ahead. Okay. Okay. So I want to give a little background on this. This project facility is primarily engaged in juice, self-stable beverage manufacturing facility. Place is given, treat process water to make it suitable for to discharge it to the city wastewater treatment. So when an industry is discharging it to the city wastewater treatment plant, we apply a pre-treatment, make it compatible with the wastewater which the receiving wastewater treatment plant can treat. We will do that and then discharge. Then discharge and monitoring parameter, average numbers are given, 155 gallon, maximum maybe 200,000 gallons. It has a BOD TSS and ammonia, pH, metal, polychlorinated biphenyl. This is our target. We are not yet finished with this, but another PFAS is already in the lab. Understand? So BOD5, that is all the components which has to be removed, main contaminants, PCB and metal sulfur. When you do reverse osmosis, it also removes the metal, right? So study focus PCB and BOD, but metals concentration was not much. So the focus was both. If any industry which is giving a BOD, you are happy because you need a BOD organic compound to survive microorganisms. There are many industry which have a very less BOD and they are have a different situation. So it compensates, win-win situation. So products 24 hours, 7-day week. How will go? Huh? No, we can go back and do that. That is sufficient. Okay. This is fine. Oh, okay. Let it be like this. I will do no problem. You guys are comfortable? Yes. Very good. So pH adjustment and chemicals used. Screens, you given a little bit of background about what kind of treatment they do. 2,500 gallons concrete tank and neutralization. You understand? Neutralization is done. What is the chemical used? Caustic soda to adjust the pH between this. This pH is decided by the receiving wastewater treatment plant, right? Before discharge to the city, the solution is partially recovered, reused with the periodic replenishment as needed and maintain concentration 1. Okay. So it has an pH variation. It is very simple. You will add some chemical, make it normal. That you already learned. Other chemicals used: sanitizing acids diluted for use and or recovered for reuse. Flow is given, how much they are discharging, because this is the agreement. When you industrial or the industrial discharge, industry discharge to the wastewater treatment plant, there is an agreement how much they can discharge. So that is the agreement there, in addition to the authorization issued by the government, right? So facility operates sprayer, salt bottles, and how the operation is taken. Their processes help to colorant in the wastewater, if at all that can be removed. There are been technologies where colors can be removed if it is slightly. But paper industry, where you do a lot of bleaching and decolorization, they are prone to color, right? So other things they are just disposed of. Sources, raw materials used, cleaning, washing. What are the activities we want to tell? I'm just giving you the highlight in background. Till next in next slides you will know what we do. Some parameters which highlights what is the concentration. You can see the concentration is so small and triggers. Group of man-made chemicals that are toxic and carcinogenic. That is what I was expecting. We make them. How this has come up? That was your question yesterday, because it has we make to make better products, better marketing. We don't see the consequences. So PCB were banned in the US 1979 internationally. PCB are still present in many products made before. Now, what they do? They just ban. You have seen earlier. Earlier, people were using DDT. We used it for many years. So other countries who manufacture, they banned long back. So we are using it. We banned that recently. You know, this kind of without understanding, we see just in one direction. It may be doing that purpose, but what are the other consequences? That was not evaluated before using. So PCB has been released to the environment, spill, leaks, electrical and other equipment, improper disposal, storage. How does the PCB gets into the environment? It is estimated that more than half of the PCB produced have been released into the environment. Once it is used, rest is just discharged, just like fertilizers. It will take 50% is the crop intake, and rest just it will be enter the groundwater or river. Similarly, but they are not that harmful. These are different. So once in the environment, PCB can be transported long distance. They bind strongly with the soil and sediment. Many people with the soil background throughout the world, they can keep flowing. It can, if it is produced in the north, if it is a river, it will go to the south. So because of PCB have not been made since 77, level of environment and food chain have been declining. I agree. They did it, they understood. Oh, this is causing more disease. Correct? Many pesticides were like that. We used the pesticides. Then we understood your crop production may increase, but it will cause more dangerous. Who will do the cost benefit analysis? Is it not necessary to do it before it is you are bringing it here? So that is the important determination we should make it. Now it is banned, it doesn't mean that it is not existing. It is decreasing, but it is there. But if you are not stopping it, if you are still using it, then how difficult to remove it? The things you can see where you can understand the way everything is tracked, but still they banned it in 77, but still we are treating 2025. Just imagine if you are still using, what will be the consequences, right? So since PCB found throughout the environment likely to everyone has been exposed, and there are list of things affect everything. Fish life, most people exposed to the PCB eating contaminated fish, meat, dairy products. Why dairy product? If PCB is there through the food chain, it enters the cow, buffaloes, the milk, the sources, right? So plant takes up only small amount of PCB from the soil, so amount of grazing animal and dairy products are generally lower than the fish. Dust contaminated with a very small level of PCB found on the outer surface of the fruit vegetables. I was giving you an example. The organically grown apple and the apples which we see round, nice, shining, there is a difference, right? So how can I be exposed? PCB do not dissolve well, so exposure to them from the water is usually not concern. Some private wells may use old submersible pumps that contain PCB oil. If it is there in the oil, that is possible. You already seen earlier what kind of fuel you were using it. It was lead content was there. Then when we came to know that, we removed the lead content from that. Is it? Then we started using it. That is how it is. So odor fluorescent light found in the school, offices and homes may still contain transformer or ballast that contain PCB. See how, from where it is coming, how you are going to find the sources. It is everywhere, because earlier people were using it, and still people are using in other countries. PCB level measured in the air after light blast failure can be significant. The workplace also may be a source of PCB exposure, right? Export to PCB depends upon the PCB quantity entering your body, how long you were exposed PCB, and how sensitive your body is to the PCB. That means how much immunity you have. Who are the prone for this kind of pollutant of concern? Children, aged people, elder people, senior people who have less immunity. They're all target. In people, PCB can affect skin and may cause, there is a disease, chlorescine, small pale yellow skin, like that. So that may last from weeks to years, kind of a disease related to the skin. PCB also can be cause short-term changes in the activity of the liver, but without any noticeable symptoms. See, that is still dangerous. That is the problem with someone was talking about a bioaccumulation. This is how. You will not even come to know it is go on accumulating in your body, and suddenly once the right concentration is done, then it flushes. You cannot do anything. So animal studies also have suggested that PCB can affect immune, endocrine, reproductive system, but these effects uncertain in humans. Animals are affected. If animals, people are not bad. People, both are affected, right? So large amount of PCB given in the laboratory animals over the short time can cause cancer. Birth defects. Pregnant woman can pass these chemicals to the unborn child. Birth defects can have been linked to the mothers who have been exposed to PCB. PCB also can be passed to the babies through the breast milk. Young children also may experience developmental health effects. If you are creating such a chemicals for using it, you can imagine, because I don't want to, don't be a terror of this, but just I'm telling you it has a big consequences. Let's go back to our thought. We have created, that is the issue. See, we are using again the biofilter system, design criteria, biodynamic air bed, influence characterization, design criteria for sizing based historical data. Historical data are important, that is why you design the system. If that data are uncertain, then that will create a lot of issues. So approximately can see design flow, P, TSS. This is all is needed for the design, and some kind of flow diagram where it is fixed that you people have worked with the industry. You always do a process plan, a flow diagram. What are the routes for getting the processed water and how it is brought out for the treatment, right? Will not spend much time on this. This is understood. Influent, effluent, and because in the industry different places you collect the processed water, right? Then you make it combine. That is how we learned earlier. You can combine inside. Earlier people used to bring it outside and then do the treatment. Now people are becoming more smarter. They want to do it inside and then neutralize and reduce. So it is a proximity facility, tanks and bida system, pre-treatment and pure treatment. That it is. Pre-treat and then discharge. Sizing, this is the process. You can see what is the hydraulic rate, what is the TSS rate, and we already learned about that. How much you can have hydraulic loading, organic loading to the treatment system. Here you can see similar way. You have seen a winery wastewater earlier. What they do is when wastewater comes out, then there are two ponds where it is collected. You have a bida system at the center, and then a big pond where you are collecting the treated wastewater, then it is supplied. But what was our earlier focus in the winery case study? Only BOD, right? Only the organic compound. Then we understood this treatment also good for priority pollutant like PCB. So one step ahead. Same kind of process can be used for removing the targeted pollutant. Okay? Here also you can see the two ponds and a much better picture here. Okay, this is the boiler system where it is applied. You can see in a different way spread in a large area. You can have a design, how much width it should be, how many slots you want, how you want to spray that, right? So spraying it, then it is going down, collected the water at the drain. So you have seen there two ponds, Vada system and the big pond, treated water. You can see the removals of this concentration. We have seen this for the BOD. We'll go back to the PCB. This you have seen earlier, some of the results. Calculation highlights similar way. Same company has done this work for both the places. Existing settling tank, new storage, equalization tank, system, then treated water and reused for the land application. So this is kind of understanding how it is the treated water is stored, how the equalization is done, influent, balance of pH, mix system, that is all done in a similar way. So what are the results? In this, contaminant is removed about 97%, BOD is removed about 95%. Success story, right? We are able to remove the PCB as well as we are able to remove organic compound. So this is the modern technology which is used. There is no aeration. We will see couple of videos there. You will understand how exactly it is applied, right? So this is the same system. How it has some kind of contaminant removal is 97 BOD, and in addition to that, TSS and others are removed 30%, 40%. We are not bothered much about that because it is going to the receiving wastewater treatment plant. That will take care of. But major portion is removed. So how then this is the great success story, because how much that agreement is done based on the organic loading. So you are removing the major organic loading and contaminant both. Your water needs a little treatment, but what they will do later, they will put some more money and make sure that everything is not done, not required. They will not discharge it. They started discharging it to the land application. So complete, they are just, earlier they were discharging there, and now they are reusing this to the land application. So we'll go and see. I don't want to say thank you. I will see some couple video how it is applied, right? So this is how it is the first time. Maybe some other places also, one or two places it is used. This is first time it is used because they have to take a risk. Risk is also important. Bigger companies, they can take a risk. They said that we will also remove. So the first time they implemented, that worked. That's very important. So they have to, new companies, when there is no alternative, they take a risk. Right? Why they took a risk? Because it was identified. Number one. Number two is they have to shut down the company itself. They just give few months of time. I remember extending it for 3 months more. If they are stepping forward, okay, we will. They spend a lot of money quickly. See, high revenue earning industry, they can do that. They took a risk, let's do this. So then analysis is done and PCB is removed. They are fine. But how we will confirm, your next question, how the PCB is removed? how we will confirm whether it is removed. That is always you should give a thought when you go, you see any technology. That is nothing is hidden. That is a simple calculation. What we do, we analyze biomass. Similarly, we analyze that whether that is been in their volume, it is present in the sludge there. If it is not, then they approve. So that means treatment is taking place. So that is how it has been done, approved, and PC was not found. So that was a success story, right? We'll go. Video.
70% of the world's water is used for farming. 10% of us eat food grown with dirty water. 47% of us could suffer from severe water scarcity by 2050. There is a limited supply of water in this world. We must protect this resource for future generations. We must reuse. Biofiltro is a low-cost solution to clean wastewater. This recycled water feeds the world's agriculture in a safe and sustainable way. The biofiltro turns the wastewater into two valuable products: clean water and organic fertilizer for agriculture. How does it work? First, wastewater from communities and industry sides. Next, the water flows into a tank. A pump pushes the water up through a parabolic filter, which retains mid-sized solids. From this tank, the water is filled into the biofiltro. The first layer is filled with earthworms. The earthworms eat the food inside. As the earthworms digest, they produce castings. The castings contain bacteria that works to eliminate contaminants dissolved in the water. Gravity carries the water down into the second layer, solids, and then in the third layer, gravel. The solids of the gravel serve two purposes. They filter out solids and contain bacteria that can process dissolved contaminants. Next, the water enters a tank. This tank includes a few drops of chlorine to finish the disinfection process. The result is clean water, ready to irrigate the world's farms. Along with clean water, biofiltro produces abundance of earthworm. The earthworm can be harvested as a healthy and inexpensive source of protein. The earthworm humus is one of the best organic fertilizers. It's an important component in healthy, unfarmed food. Biofiltro is a low-cost solution that transforms wastewater into clean water for agriculture. At the same time, biofiltro produces organic fertilizer that help crops grow healthy and strong. Biofiltro, low-cost water consumption technology that any worker can manage, using 80% less energy and producing no emissions and no pollutants. It's a profitable, sustainable business.
We'll go to end. Just for a pass. Okay. So did you see that how that system works? Yeah, I think it's central. Oh, is it there?
Give us 4 hours, and we can remove more than 90% of contaminants from wastewater.
Yeah.
Give us a month, and we can reduce greenhouse gas emissions. Give us a year, and we can generate verified carbon credits. Give us more,
Yeah.
and together, we can change the world. Biofiltro, low-powered solutions.
Okay. That was. It's fine. I think. Okay. That's fine. We'll go back to that tutorial. Okay. Okay. It's already there. Right? Any questions on that? See how nice technology. Is it different? No, it was happening in a very small scale. What they did is They took earthworms, they made and mixed with other bacteria, and they developed the system. See, I told you they live for a small fraction of second and they do such a important work for the people. And what we do, we produce such chemicals. So we use it, then we understand. So that is the issue. So that should not be the thing. But when we do, if they are prevented in the beginning, if we have a good understanding of these chemicals, whether that can be used or not, that will make a lot of impact. So you created the environment. See, if you used that for a few years, and what they are doing, it is stopped in 77, and now you are cleaning up. So that is the situation. You can understand if you are still using, what will be the consequences, how many people are affected, because you have seen few of them, you can, there is a big list, right? And that is what I was telling, these are the emerging contaminants. They understood, and then, but what about other countries, other areas, whether we are using it, who knows? So that all has to be evaluated when this pollutant of concern or a great threat currently to the environment, soil, and the water quality. Right? So that is why we have to be more cautious on that. So that concludes this tutorial. If you have any questions, let me know.
Any questions? Any query?
Do you have? No one? Careful. Very nice. Thank you, everyone. It was great working with you all, and I hope it was useful for you. And I developed a very good course where you can combine and see visually what is happening and what is there in the system. Want to say that the model can be built in a similar way, and we can keep the environment safe, or waters of the state safe, and a safe environment, good water quality, and good soil. That is very important. That is the need of the hour. Everyone must be concerned about it. Thank you. Thank you very much.
Thank you, sir. Thank you very much, sir.
Please just take that.
In this way, tutorial 5 has been completed, and overall we have completed almost 13 hours of lectures. In total 10 lectures. We will stop here for a break, and then we will meet after 15 to 20 minutes for certificate distribution. Thank you.